Importing Dynamix 1444 spectrum and time waveform data into Emonitor CMS 4.0. The first step that we need to ensure is that the 1444 modules are communicating successfully with RS Links Classic. To do this, we'll go to Start, All Programs, Rockwell Software, RS Links, and then we'll go to launch the Launch Control panel. We can see that Links is actually running already, not as a service, but that's okay. We'll go to the System tray and launch RS Links, and click on the RS Who button. We can see under AB ETH1 that we have one Dynamix 1444 module, and it appears to be online and communicating. So we'll exit Links. And we do highly recommend that you do run Links as a service. It's not a requirement, but a recommendation. So we'll stop RS Links. We'll check the box to always run it as a service and restart it. Once we verify that Links is running, we can go ahead and close the Launch Control panel. Now, on our Logic Studio AOP, we need to make sure that the controller is set up to be the time sync master and that it has the correct date and time. On the module AOP, we need to go into the measurement definition channel pages on the FFT page and ensure that both time waveform and FFT measurements are enabled. And we want to repeat this for all 4 channels. Finally, on the trend page of the module AOP, we want to go to the dynamic data section and ensure all 4 boxes are enabled. If you've made any changes, be sure to download them to the module. Now we'll go into Windows Services. After installing Emonitor, you will see 3 services specific to Emonitor. The Emonitor DDM service controls our communication between the Extraction Manager utility and the 1444. It's disabled by default, so we need to change this. We'll set it to an automatic delayed start, so if the machine is ever restarted, it gives RS Links a chance to start up first, and then we'll click Apply. We may also need to start this service if it's not already started. Then click OK. The online service, the Emonitor online service, controls the online data management console, and that's where we configure connections to NWatch, XM, OPC, that kind of thing. The Emonitor scheduler is also important. In this case, it is what allows us to process unload files from our 1444. So we'll set its startup type to automatic, and then we'll make sure the service is started, and we'll click OK. Now we can verify that all 3 of our Emonitor services are started, and we'll exit the services. Now let's go set up Scheduler now that it's actually running. To find it, we'll go to Start, All Programs, Rockwell Software, Emonitor, and under Utilities, pick the Scheduler option, and we're going to click the Add button to add a new scheduled profile. We'll give it a simple name. We'll just call it Data Imports, for example. You can call it whatever you want. And we'll click Next. By default, it's going to tell us that we can check the scheduled time and date frequency. We'll go ahead and uncheck this option for now, and we'll check Manual Launch and File Change Notification. This will allow us to process files as they arrive. Click the Settings button, click Add File, and now we're going to navigate to the UD folder. This is our default unload folder for unload files. Open that folder. And to look at the path, you'll see it's located under C, Users, Public, Public Documents, Rockwell Software, Emonitor, and UD. Now we want it to process any file with an ULF extension. So star.ulf is what we type in file name. And then we'll click Open. Click OK from here. and then we'll click Next. Now we need to tell it what to do with that unload file when it finds one. So we'll click Add Event, and in the Executable File field, we'll click the Browse button to the right. This folder is located under C, Program Files x86, Rockwell Software, Emonitor. We want to browse until we find the executable called di-daemon. There's a few files in here beginning with D and ending with daemon, so make sure it's DI and not some other letter combination. And then we'll click Open. Now we're going to copy the path string in the executable field to the command line. So select that entire path, copy it, and then paste it to the command line. Now we don't need the di-daemon portion of this string, so we are going to carefully backspace over this, and we're going to replace di-daemon with odonline.edi. This is a parameter file that's created when Emonitor is installed, and it already contains your specific database connections. Once you're satisfied you've got the right name typed in, click OK, and then we click Next. And since we disabled the scheduled collection, nothing to change here, we'll just click Finish. And now we've got a scheduled profile. Go ahead and exit the scheduler. Let's go ahead and launch Emonitor. Basically all we need to do here is to create a piece of hierarchy that would indicate where we're going to map data to from our 1444 module. So I'll right click a piece of hierarchy and I'll choose Insert and give it a simple name. This can be positioned at any of the levels of hierarchy. We'll just keep it at the top level for now. And that's really all we need to create within Emonitor. The Extraction Manager utility will create our locations and measurements for us. So let's go launch the EEM utility. So start All Programs, Rockwell Software, Emonitor, Online, and then the Emonitor EEM or Extraction Manager. When it opens, we first need to log in order to do anything. So we'll give it the default Emonitor user admin credential and click OK. And we notice that it's currently connecting to the Emonitor database, which is the same one that Emonitor is using. This is important because we want to make sure that we're unloading or mapping to the correct database. We'll click the New button, and we're offered a choice between the live data or demand data buffers. Live data will take the data as configured in the AOP, whereas demand data allows you to specify the measurement setup. We went with live data, and then we click Next, and we're picking the module from our list, and then we click Add Device, and then Next. Now we're looking at our module channels, and we can see that there's spectrum and waveform underneath each channel. Again, if you don't see these measurements present in this screen, it means the module is not configured properly to show this data, and you'll need to take care of that before proceeding. So once we've got our measurements available, we can click this top button at the module level, and it automatically selects everything beneath it. And we'll pick the item where we want to map data, and then we click the Auto Map button. And you can see it creates these measurements on the side automatically. We'll look at those in a minute. Go ahead and click the Next button, and we're offered the option to store phase. We'll skip that and click Next. Now we can give it an extraction interval. So for demonstration, keep it simple. I'll just choose 1 minute. And now we have to save this extraction and give it a simple name. And then click Save. Finally, we'll click Finish. So now our extraction is completely configured, but it's currently stopped. We have a green check mark indicating that we have successful communication to the module. But there's a couple things we need to do first. We can press F5 in Emonitor And notice that we suddenly have a bunch of locations and measurements. These were created for us automatically by the AutoMap. But the collection spec column is blank. So we're going to create a new one. And the most important thing here is to ensure that the signal detection that we designate matches the actual signal detection that we've set up on the AOP. Emonitor will always store the data as an RMS value. So if you've picked a signal detection on the module as something other than RMS, you'll get amplitudes that are different than what you expect. So to make sure that those are interpolated correctly, we want to make sure that the signal detection field matches what's in the AOP. Everything in this resolution box is not important, but we can match it to the module just for convenience. And then we'll click OK. Now, rather than key this in and all these other fields, we can just copy it there pretty quickly. So we'll go to the Edit menu and choose Replace. We'll tell it to look in specifically the measurement def pane, and specifically inside the measurement def pane on the collection column. Now we can hit the C key a few times, maybe 2 or 3, and it'll eventually pop down to our collection item. And we want to say where collection is equal to nothing or null, we are going to replace that collection value with the new collection spec we've created called the 1444_data. So we'll just type that in. We can also double click that field and select it. And then we'll choose Replace All. Just acknowledge those prompts, and you can see that now we have all of those empty collection specs now filled in. So now we can go ahead and start the extraction. So we'll click the Start button, and you can see the status is now started. If we were to right-click under Startup Type, you can see that we have the option to start up. We can stop it. We can set the startup mode to automatic. It's currently grayed out now because the extraction is currently running. If we stop it, we could actually change it to start as automatic. But once you start data collection, it's common for it to take a few minutes before you get your first sample. So we've got a first sample. To look at it, we can just simply do a quick right click and show data, which you can do on any measurement. It'll bring up a plot of that data. So there's our 1444 spectrum. We could also click on the plot icon on the toolbar and choose Auto View, and it'll give us plots for all measurements for that location. In this case, one time waveform and one spectrum. I'll speed up the process here on the video, and we'll get a few more measurements to inspect. So giving it just a minute here, we can stop it at 4 measurements. But once again, if we go to the plot icon and we pick, let's go waterfall this time, click OK, and you can see we've got our spectra. Thanks for watching.